Alright, so in the last video we went over some examples of how to use the arithmetic sequence. In this video we're going to go over arithmetic series. So arithmetic series. So what is a series? A series is just basically where we're adding up numbers. So say for example we take a very common sequence which is 1, 2, 3, 4, 5, 6, and so on and so forth. This is the sequence. This is the sequence. Okay. A series is where we want to add up all the numbers of a sequence. So say for example we wanted to add up 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus and so on and so forth. This is a series. So that's the difference between a sequence and a series. Okay, so if you recall, the general formula for an arithmetic series is the following. It's Sn is equal to n over 2 times 2u1 plus dn minus 1d. This formula will be in your formula booklet, but I highly recommend that you memorize it. Another version of this is it's basically n over 2 and it's times u1 plus un, which basically means it's n over 2 times the first term plus the last term. So if you have the first and last term and you know the number of terms, then you can find out what the sum is. This basically stands for the sum, okay, the sum of a sequence, all right, or otherwise known as the series, okay. So and the n here stands so for example, if I write S6, it means the sum of the first 6 terms of the sequence. So let's just go right into it. Let's just go over some examples of how we can use this formula. So the one example that I have is, this is one example. So this is 2 plus 5 plus 8 plus 11 plus ... all the way to 296. So the question is, what is the sum of this series, right? So if we had to use the equation again, I'll write the equation again. It's n over 2, which is 2u1 plus dn minus 1. Okay, so let's look at what we have. So we don't have the number of terms. We do not have the number of terms because we just know that this is what we have to sum up, but we don't have the number of terms. We have u1? Yes, we definitely have u1, and that is 2 right there. Do we have the common difference 3? Yes, we can pretty much determine that. It's going to be plus 3 each time, right? So the common difference, we have that, so no problem. So what we need in order to find the sum of this series, or sum of the sequence basically right here, is we need to know the number of terms. And anytime there's a variable that you don't know how to solve, you must go back to the sequence equation, right? So the sequence equation is the following. It's un is equal to u1 plus dn minus 1. So first we have to determine n, and anytime you don't know one of these variables, go back to the sequence, figure what that is, and then come back to the series and then solve that. So we have to determine what n is. We know the last term is 296, so that's 296 right there. We know the first term is 2, so that's great. We know the common difference is 3, so that's great. So it's n minus 1. So we got to figure out what n is. So this is going to be 294, because I'm just subtracting 2 from both sides. 3n minus 1. The next thing I'm going to do is divide by 3. So I'm just running out of room here. So let me just do that. So basically it's going to be 294 divided by 3 is equal to n minus 1. 294 divided by 3 is actually 98. Is actually 98. Yes, that's right. So it's equal to 98. So n minus 1. So therefore n is equal to 98 plus 1, which is equal to 99. So there are 99 numbers. Okay. So basically, let me just go up here. So n equals 99. 99. So once we have that, right, our goal is to find the sum of this. So as we said here again, so since we know there are 99 terms, we can write it's S99 because we're summing up the first 99 terms of this sequence, which ends up being a series. So it's 99 divided by 2. I'm just following this equation right here. 2 times 2. So in other words, 2 times the first term, which is 2. And the common difference is 3, so plus 3, n minus 1, so it's 99 minus 1. And then we close that up. So all you have to do is pretty much is just plug this into your calculator right now. So 99 divided by 2 and all that. And what you should get is 14,751. And that will be the sum, basically, of all these numbers from 2 to 296. Okay, so that was our first example. So the key thing here is that when you're trying to find the sum and you don't know one of the variables, so we know u1 and ud, we know u1 and d, but we didn't know n, we didn't know the number of terms, go back to the sequence equation. Go back to the sequence equation, figure out the variable that you need to find out, and then plug it back into the series equation right here. All right, so let's go over the next one. The next problem I have is something that looks like this. So it's kind of like a visual representation of a of an arithmetic sequence or series. So say, for example, you're just piling boxes. So you pile one on top, you pile 2 there, and then you pile 1 here, 1 here, 1 here, and then you pile 1 here, 1 here, 1 here, 1 here, and and so on and so forth. Like you just keep on piling boxes right there. So the question that I have is, so the question here is the total number of boxes in this pile equals 300. Okay? So my question is, how many rows are there? So how many rows are there? So the question is, how do we determine that? So basically, because they've told us, whenever you hear the word total, and especially when it relates to arithmetic sequences and series, when you hear the word total, that should sort of ring a bell that they've given you what the sum is. So in other words, they've told you that Sn is equal to 300. Okay, so Sn, because they just explained the total. So let's look at, if Sn is equal to 300, let's look at some other variables. We know right away that the first one, u1, right, u1 is right here. So in other words, it's equal to 1 because we have one box on top, right? u2 is equal to 2, u3 is equal to 3, and so on and so forth, right? So u1 right away is equal to 1. Now, what is the common difference, right? Because that's also another important thing. So if u1 is 1, u2 is 2, we can see that it's constantly increasing by 1. So what do you think d should be? D should be 1, because obviously it's increasing by 1. So now the goal is, how many rows are there? So in other words, what we need to find out is what is the number n, right? Because we need to find out the row at which the sum of everything will add up to 300. So how do we do that? So the way we do that is we use the Sn equation. We know that Sn is equal to n over 2, 2u1 plus d n minus 1. You might ask the question, well, why don't we just use the sequence formula, which is like, un is equal to u1 plus dn minus 1. The reason why we can't use the sequence formula is because even though we know u1 and d, we don't, and we're trying to find n, we don't know what un is. We don't know how many boxes are in that last sort of row. Because if we did, then we wouldn't even have to, you wouldn't even have to know that there are 300. But we know that 300, we know that that their u1 is 1 and d is equal to 1. So how do we find n? So let's plug in some numbers. So we get 300 is equal to n over 2. 2 times 1 plus d is 1, and this is n minus 1. So our goal is to find out n, so in other words, the number of rows, right? So the position of the sequence. So this is equal to, so let's just simplify this for a second. So this is n over 2. This is 2 plus n minus 1, which is n over 2, which is equal to n plus 1. Okay, so 300 is equal to n over 2 times n plus 1. I can multiply both sides by 2, so basically I would get 600 is equal to n times n plus 1. And what I can do now is I can expand, so it's equal to n squared plus n. And then if I bring everything, so what you'll observe that it's sort of forming into a quadratic. And it forms into a quadratic, it becomes 0 is equal to n squared plus n minus 600. So if we want to find n, we need to use the quadratic formula. So if you remember the quadratic formula, n equals negative b plus or minus square root of b squared minus 4ac, this whole shebang, over 2a. So this is going to be, our b here is 1, so negative b is negative 1, plus or minus 1 squared minus 4, a is equal to 1, and c is equal to negative 600. Okay, all over 2a, so 2a is equal to 1, so 2 times 1. Now if you plug this into your calculator, you'll get two answers. The first answer you'll get is 24, right? And the reason why you get 24 is because you get two answers because of that plus or minus. So you have to plug everything with the plus and then with the minus. Or you'll get negative 25. And clearly you can't have a row number that is negative, so this is not applicable. So we have basically 24 rows. So if we stack 24 rows of this, so what this means is if we stack 24 rows of these piles or boxes or whatever you want them to be, if we have 24 of these rows and we add them and count the number of boxes in total, we will have 300 boxes. All right. So that's basically how you can use the series formula to figure out the number of rows. So that was part A. Okay. I have a second part question, which is part B. So part B is how many cans are in the bottom row. So how many cans are in the bottom row. Since we know there are 24 rows, so we know that n is equal to 24. And if we want to find out the cans in the bottom row, then we have to go back to the sequence formula. So it's un is equal to u1 plus dn minus 1. Since we know that n is equal to 24 and u1 is 1, and we also know d is 1, so it's 24 minus 1. So it's equal to 1 plus 23, which is equal to 24, which makes sense, right? Because since the row was 1, we had 1. If the row was 2, we had 2. So if we're on the 24th row, we should have 24 cans in that bottom row. All right. So that's the equation, or that's basically the example so far. In the next video, we're just going to go over geometric sequences. And we're going to go over geometric sequences in series. All right, so see you in the next video.